Hi, so here we have a football game going on, and it's some way into the second half, and the coach wants to make a substitution. So player 1 comes off and player 2 comes on, and there we have a substitution. Now that was substituting in football, but this video is about substitution in algebra. So it's time to get your notebooks and pencils ready, and we will begin. The first question talks about finding the value of the following expression if a equals 5, b equals 2, and c equals 9. And here's the expression, a squared plus b. Now, the first thing I wanted to mention was that find the value is another way of saying evaluate, or evaluate is another way of saying find the value of, which basically means find out what this expression is worth. How much is it worth? Okay, but I wanted to start using the word evaluate, so that means find the value of. Right, well, let's begin. So we're going to make a substitution. A is going to come off and 5 is going to come on. B is going to come off and 2 is going to come on. In that way, it's kind of just like football. And now we can evaluate. So remembering back to BIDMAS, we will do this index number first. We'll work out what that's worth, which is 25. And then we will do the addition. So 25 plus 2 is 27. Right, well that was done. That's how hard it really was. We substituted A for 5 and B for 2 and then worked out the answer. Simples. Here's another expression. A brackets C take away B, close brackets. And another substitution. A for 5, of course, C for 9 and B for 2. Right, well now let's work out what that's worth. 5 on the outside of the brackets, and then we work out what's on the inside. That's the first thing to do according to BIDMAS. 9 take away 2 is 7, so that's what's left inside the brackets. And now you're thinking, well, I haven't seen something like this before. A number next to a pair of brackets with only one number inside. Well, it's the same rule that applies. You've got the number on the outside touching the brackets, it means multiply. So 5 times whatever's inside the brackets will give you 35. 5 times 7. Okay, well that was substituting. I'm going to give you just a couple more questions looking like this. This might be a question that you get where you have to apply your knowledge of substitution. So it says, which expression has the greatest value when z equals 12? This first expression is 3z. As you know, it stands for 3 times z. Okay, but we're going to substitute z for 12 and work out the answer. We're going to evaluate it. It's 36. Next one stands for 4 times 12, take away 13, which is 48, take away 13, which is 35. So far, this one is bigger. This stands for 2 times 12 plus 13, which is 24 plus 13, which is 37. Right, this one is actually bigger so far. How about the last one? 5 times 12, take away 25 is 60, take away 25, which is 35, same as the second one. So it turns out that this has the greatest value when z equals 12. Last question. Decide whether each equation is always, sometimes, or never true. Doesn't really tell you any more about how to do this. It says 2d equals d squared. Is that always, sometimes, or never true? Well, here's how I'd go about it. If I substitute d for a few numbers, so if I swap d out and put some different numbers in, let's see what I get. Sometimes I might find that 2d is always the same as d squared. Sometimes I might find that 2d is the same as d squared. Sometimes I might find that it's always the same, or I might find it's never the same. Well, the only way we can test that is by putting in some different numbers for d. So let's say that d equals 1. Then on this side we would have 2 times 1. And on this side we would have 1 times 1, because that's 1 squared. 2 times 1 is 2, 1 times 1 is 1. They don't equal each other. So we know that it's not going to be always true. Let's try, if d was 0, 2 times 0 that would be, is 0, and 0 times 0 that would be, here you'd get 0 and here you'd get 0. Right, so in that case it can be true some of the time. Presumably that means, yeah, so obviously it's not never, because we found a case where it is true, so it must be sometimes. Another example when it is true is if d is 2, and you get 2 times 2, yeah, and over here d squared, that would mean 2 times 2 as well. Of course they equal each other, so sometimes true for that one. What about if we had an equation 4 divided by w is equal to w divided by 4? Well, let's say that w is 1. Then you get 4 divided by 1 is what is 4, but over here we try to do 1 divided by 4, we get a quarter. So we know that it's not always true. What about 4 divided by 2? That gives you 2, but 2 divided by 4 gives you a half. So at the moment we're not finding anything that makes it true. 4 divided by 0, I could try. Well, and 0 divided by 4. You can't actually divide 0 by anything, so that gives you an error, so that's not true. But I have got one more that I think might just work. 4 divided by 4, so this is where w is equal to 4. And over here then that would be 4 divided by 4. So in this case they will equal each other. So that means that must be sometimes true. Okay, and then the last one, r plus r equals 2r. If I substitute, let's say r for 1, then I would get 1 plus 1, and here I get 2 times 1. Well, they're both equal. If I substituted r for 2, I'd get 2 plus 2, and that would then be 2 times 2, and they're equal. If I did r is 10, I could do 10 plus 10, and then over here I would do 2 times 10. They're both 20. If I did if I did 50 plus 50, let's say that r was 50, 2 times 50, they're both 100. Well, it looks like they are always going to be true. Okay, now that's obviously the case. R plus r is the same as doubling something. If you have a number and you double it, it's the same as adding it to itself. So I kind of always knew that was always going to be true, but that's how you might go about testing it, just putting in different numbers, substituting r for different values. Okay, well, that was the end of that video. Feel free to go back, rewind, and play the bits that you need to play again. But yeah, that's it. Thanks very much for watching. Okay, bye.